So in example 5, a cosmetics company fills its best-selling 8-ounce jars of facial cream by an automatic dispensing machine. The machine is set to dispense a mean of 8.1 ounces per jar. Uncontrollable factors in the process can shift the mean away from 8.1 and cause either underfill or overfill, both of which are undesirable. In such a case, the dispensing machine is stopped and recalibrated. Regardless of the mean amount dispensed, the standard deviation of the amount dispensed always has a value of 0.22 ounces. A quality control engineer routinely selects 30 jars from the assembly line to check the amounts filled. On one occasion, the sample mean is 8.2 ounces and the sample standard deviation is 0.25 ounces. We want to determine if there is sufficient evidence in the sample to indicate at the 1% level of significance that the machine should be recalibrated. All right, so let's first notice that kind of the status quo, what we've been dealing with all along, is the machine is set to a mean of 8.1. So we want that to be our null hypothesis, that the machine is set to 8.1. So we want that the mean mu is 8.1 ounces. Oops, 8.1. Now the alternate. Well, in this situation, let's notice that both underfilling and overfilling were a problem. So we want to know if this is not equal to. So let me insert a not equal to sign. (8.1). All right. And then alpha was, I believe, 0.01. Let me look back to be sure. A 1% level of significance. Yes, it was. Okay, now, before we do anything else, let's take that 1% level of significance and let's find out what our critical values are. Now, since it's a two-tailed test, we're going to do this by looking up half of alpha, because we have to divide that area in two, because we have two different tails, two different rejection regions. So that's going to be 0.005. Now, when we put 0.005 into Excel, it's going to give us the negative critical value. And since our normal curve is symmetric, the positive critical value will be just the opposite. All right, so let's get our two critical values. By putting 0.005 in, I'll do equal norm.s.inv 0.005, and I get negative 2.576. Okay, so negative 2.576, and then as I said, we have another one on the right side of the curve, which is the exact opposite, positive 2.576. Now be careful when putting these critical values into your homework. Sometimes the plus and minus will already be sitting in front of it, so all you got to do is type in 2.576. All right, now let's look at a picture for a second of what a two-tailed test looks like. I've drawn this here. All right, so we have two tails. So we have a shaded area over here and an area over here. And of course, the mark here is negative 2.576. I can't draw that very well. And then this mark here is positive 2.576. All right, so in a moment, we're going to do our test statistic using the formula that we used in the last one. If our test statistic either falls to the left of negative 2.576 or to the right of positive 2.576, it will be in a rejection region, and we will reject the null. All right, so let's go back and let's make that calculation. All right, so Recall, we're going to use that same formula we've been using all along, x bar minus mu over the standard deviation divided by the square root of the sample size. All right, so let's see what our x bar was back in our example here. X bar was 8.2 and the standard deviation was 0.25 and there were 30 jars. Okay, so 8.5. So we're going to have it was 8.2 minus 8.1, our mu from our hypothesis, our first hypothesis, our null, and our standard deviation was 0.25. And I want to divide that by the square root of our sample size, which was 30. All right, so let's do that. On top, we're going to get 0.1. On the bottom, when we stick that into our calculator, we're going to get 0.045644. Take that out about 6 or 7 decimal places in order to ensure accuracy. And when we divide this out, we get 2.191. All right, so let's take a look at 2.191. If we look back at our picture, 2.191 is not in this rejection region. In fact, it's over here somewhere. Remember, zero's in the middle. So 2.191 is right in here, which is not in the rejection region. So let's go back here. Let's write this is not in the rejection region. And if it's not in the rejection region, we fail to reject the null. All right, so since we failed to reject the null, let's now make our conclusion. There is not enough evidence to reject the null, and alpha is equal to 0.01. Now, since we are not rejecting the null, it appears that the machine is at present properly calibrated. It does appear to be filling the jars to 8.1 ounces. And there we have it.